In this final section, 11.5, we will talk about matrix multiplication. We will talk about multiplicative identities, meaning the identity matrix in the multiplication world. And finally, we'll mention a little bit about inverses. Now, I can show you how to multiply things by hand. As a matter of fact, I'm going to do the first couple problems like that, just multiplying them by hand. But ultimately, I think you've earned a little break and you can use the calculator to do pretty much everything in this section. So I'm going to let you do that. I'm going to just show you a couple of problems by hand, and then I'm going to tell you how to do the ones with a calculator, and you can try out the rest of them with a calculator. So I just want to tell you basically that it exists and show you just in case you want to know. Now, the important thing when you're multiplying matrices is that for the matrix multiplication to work, you're going to start with the size A for m by n. The size of B is going to be n by p. Now, for the multiplication to work, you want this number here to match with the number right there. So in other terms, you want the column's number in the matrix A, the first matrix, to match the number of rows in the matrix B, the second matrix. Otherwise, the multiplication does not work. It cannot be done. And let me show you what I'm talking about with this first problem. So this first problem has matrix A, and the size of the matrix right there is 2 by 3. And the size of the matrix B is 3 by 2. So that means the product is going to work. The reason why it's going to work is because the 3 here matches the 3 there. And actually, the answer that you're going to get will have size 2 by 2, the other two numbers that you didn't look at. This is the size of the answer, basically, when you multiply the two matrices. So I'm going to show you how to multiply the first problem, the matrix A with the matrix B. And the order here is really important because if you flip the order, the answer turns into something completely different. So I'm going to write down the first row of A, the second row of A, and then I'm going to write down the matrix B, and it has the numbers 1, 6, 3, negative 5, and then negative 2, 4. Now, multiplying is going to be strange. Here's what we're going to do. We're going to grab the 3 numbers in the first row and multiply them by the first column in the second matrix. And what do we get? So multiply 3 by 1, you get 3. Multiply 1 with 3, you get 3. Multiply negative 1 with negative 2, and you get 2. Finally, add them all up. And that's your answer to start with. That's the first answer in the 2 by 2 matrix. Remember, there's going to be a 2 by 2 matrix at the end. And so there's going to be 1, 2, 3, 4 numbers. The first number is finished. Now, we're going to repeat the same process again to get the second numbers. So, to get the second number, the one that goes next to it, we're going to multiply the first row with the first column. Okay, first row, first column gives me first row, first column answer. Earlier, I did first row, first column. I got first row, first column. Now I'm doing first row, second column. So that's going to give me the first row, second column answer. So let's give it a shot. 3 times 6 is 18. 1 times negative 5 is negative 5. And then negative 1 times 4 is negative 4. That is the answer that goes in the second position. Okay, now suppose I want this solution that goes right there in that corner. This is the second row, second column. How can I get the answer there? I would have to multiply the second row with the second column to get the answer that goes in that spot. And again, when I multiply them, I multiply basically the first one with the first one, the second one with the second one, the third one with the third one. And I just record the answers. So 2 times 6 is going to be 12, 0 times 5 is going to be 0, and then 3 times 4 is going to be 12 again, and I just add up the answers at the end. And that's how I get the answer there. Finally, if I want this one, this is the second row, first column. So how can I get it? Multiply the second row with the first column. And again, you multiply each number with the corresponding number. 2 with 1 gives us 2. 0 times 3 is going to be 0. And then 3 times negative 2 is going to be negative 6. And then you just add them up or subtract them depending. And that's basically how the multiplication is performed. Now, at the end, you're obviously going to need to write down the answer to this. So the answer is going to be 8. And then 18 minus 5 is going to be 13. Minus 4 is going to be 9. 2 plus 0 minus 6 is going to be negative 4. And finally, 12 plus 12 is going to be 24. And that's the solution. Let's try to do this with a calculator. So before I type in the product A times B, let me show you what I put in for A and what I put in for B. So if I go to my matrix menu and I call on A, you'll see the matrix A is the one that was on the paper. I'm going to go to second matrix again and call on B. So if I call on B, I'm going to see the matrix that I typed from the paper, basically. And this time I'm going to do the matrix A times the matrix B. So I'm going to go second matrix, and then I'm going to type in 1 times matrix B, which is the matrix number 2. And just hit enter, and then that's it. You get the solution. And as you can see, it's a 2 by 2 matrix. And this is the same one that we had on the paper when we worked it out by hand. Now, if you reverse the order, if you put the matrix B first and multiply by the matrix A, then you will get something way completely different. All of a sudden now we have a strange answer. It has 3 rows and 3 columns. And that all has to do with the size of the original matrix A and B. Since the original matrix A and B were 2 by 3 and 3 by 2, when you multiply them in the order A times B, you get a 2 by 2. The answers are going to be 2 by 2. That's the reason why this matrix here was 2 by 2. However, if you do B matrix first, so if you do B times A, the matrix B is 1, 6, 3, negative 5, negative 2, 4. That matrix is a 3 by 2. If you multiply it by the matrix A, which is 3, 1, negative 1, 2, 0, 3, the size here is 2 by 3. So since the two numbers, first of all, match, then the outside numbers are going to predict the size of your solution. So in this case, the answer is going to be a 3 by 3, and that's the one we saw on our screen on the calculator. Now, if you're wondering how we get these answers, so let me show you just how to get one of them, for example. Suppose I wanted this answer right there in the middle. First of all, where is that answer? It's on the second row and in the second column. So what do I need to do it? I need to multiply the second row with the second column numbers. So if you multiply them, 3 times 1 is going to be 3. Negative 5 times 0 is going to be 0. Add them up, and your solution is what goes inside of that position. And so you see it works. Suppose I wanted a different one, for instance. Suppose I wanted that one right there. That one is the third row and second column. So take the third row with the second column and multiply them, and let's see what happens. So let's see, 2 times 1, negative 2 times 1 is going to be negative 2. And then 4 times 0 is going to be 0. Add them up, and you get, at the end, negative 2, which goes in that position. So that's how pretty much the calculator is doing all of these problems. Okay, so type in C into the calculator and see if you can do the next few parts of this problem. So let's try out BC. So the matrix B multiplied by the matrix C. So matrix B is number 2, and I'm going to multiply it by matrix C, which is number 3 in the list, and there it is. It works out. So the size is fine. Now let's try if A times C works. So the matrix A is number 1 multiplied by matrix C, which is number 3. And unfortunately, as you can see, the dimension mismatch error happens on the screen, which tells me that the matrices cannot be multiplied. And again, why is that? Well, keep in mind, the matrix A was a 2 by 3. That's the matrix A. And I want to multiply it by the matrix C, which is a 2 by 2. And unfortunately, these two numbers, 2 and 3, do not match. So there's no match. That means that the product cannot be done. So no product. These two matrices cannot be multiplied. Oh well.